Do not use a calculator for this problem. Find the x value where the relative maximum of this is closest to x equals 0 occurs. When you need to solve for an expression equal to 0, use Newton's method, starting with x equals 0 as your first guess, and enter your second guess as the answer, and put it in as a fraction. Okay. Well, first off, here's Newton's method, Newton's formula. Newton's method. Here's the formula for Newton's method. X2 is x1 minus f of x1 over f prime of x1. Okay. So anyway, so what do they want us to do? They want us to find a relative maximum of this. So let's come over here for a second and write y equals e, and I'm going to make that 1/6 x minus x squared. And they want a what? Relative max. Well, how do you find the maximum of it? You take the derivative and set it equal to 0. So what's the derivative of this first part? E is our favorite function. He does nothing. But since the inside, this part, is not a simple x, you got to multiply by the derivative of the inside, which is 1/6. That was the chain made that happen. Minus 2x, right? The derivative of that part. And you want to do what? You want to set it equal to 0. Because why? Because you're trying to find a maximum. That's how you find a maximum or minimum, right? The peaks and the valleys, the slope, the derivative is 0. It's flat. So take the derivative and set it equal to 0. So I want to solve that equation equal to 0. So that's my desire. They're asking me to basically solve e to the 1/6 x times, I'll put the 1/6 in the front there. Let's put this guy in the front. It's easier that way. Solve that equal to 0. So that becomes my function. That's my function now because that's what I'm trying to solve, which is, you think, what's the derivative? Yeah, it's the derivative equal to 0. That's the function I'm trying to solve now. So, and I'm going to solve with Newton's method. Solve this with Newton's method. So forget about everything else. Just forget about all this stuff. Comes down to solve this now with Newton's method because that's the function we're trying to solve. How do you solve anything with Newton's method? Well, you do this. And they said when it's time to solve, right? When you need to solve for an expression equal to 0, that's what we need to do, right? Use Newton's method. Start with x equals 0 as your first guess. Enter your second guess as the answer. All right. So they're saying, oh, okay. So you gotta find x2 here. And x2 will be x1, which they said is 0. Start with 0 minus f of 0. Again, x1 is 0, 0, 0 over f prime of 0. Where, okay, so I got to do that. This is the function we're talking about. So therefore, I've got to find those different things. So let's find the derivative of this because we need, right? Because we need f of 0 and f prime of 0. Here's the function. What is the derivative function of that? The derivative of that, well, the 1/6 just sits there in front. Anytime you have a number multiplying, those just sit there. The e, take the derivative of the e. He's our favorite one, does nothing. But again, times 1/6, another 1/6 because we're doing another derivative. Chain rule. Minus 2. The derivative of that part is just that. Okay, so there's the derivative function. And now what do we want? We want f of 0, and then we want um, f prime of 0, right? We need f of 0 and f prime of 0. So what is f of 0? Well, take this function and plug in 0. It's 1/6 e to the 0, 1/6 times 0 if you want, times 0, minus 2 times 0. And that is 1/6 e to the 0 minus 0. Let me break a little more room here. And that is 1/6 times 1. That's 1/6. And now what is f prime of 0? Well, 1/6 e to the 1/6 times 0 times 1/6 minus 2. So that'll be 1/6 e to the 0 times 1, 6 minus 2. That'll be 1, 6 times 1 times 1, 6 minus 2. That's 1/36 minus 2. We'll get that as a fraction. Put that 2 over 1. Multiply the top and the bottom by 36. That's 1/36 minus 72/36. And that is minus 71/36, isn't it? Read that a little bit better. Okay, so that's f prime of 0. All right, back to this problem. That was a lot of work. So we got this right here. We bring that down here. So we've got x, let me kind of section this off. X2 is 0 minus f of 0 over f prime of 0. So x2 is 0 minus f of 0. What did f of 0 come out to be? 1/6. Over, what is f prime of 0? This. Minus 71/36. What a mess. Yep. You know how to do it though, right? Fraction on the bottom fraction, just flip it up. So it's going to become x2. The 0 is gone. Minus 1/6 times negative 36 over 71, right? Because dividing is upside down multiplying. All right. So what happens then? 6 goes into 36 6 times. The two negatives make a positive 6 over 71. Is that their answer? 6 over 7. And you can type this stuff into Desmos, also these fractions, and Desmos will do those fractions for you also. And so there we go. That's how we do that. We use the Newton's formula, but first they wanted the maximum of that function. So to find the maximum, you take the derivative and set it equal to 0. Then to solve this, we call that our function, and we plug that in for Newton's method. So to use Newton's method, we need the function and the derivative of the function. Plug in 0 to the function, plug in 0 to the derivative of the function, and put f of 0 over f prime of 0 and simplify. And so there we go.